Alright, welcome back. So hopefully you've had some time to explore this really simple activity for encoding information instead of encoding them in a traditional number sequence or anything like that. We are using really simple shapes with a fixed number of colors and talking about maybe the combination of shapes, although that is actually pretty complex, and why we don't generally try to combine shapes on our systems. So when we take a look at the very first thing I asked, which was if you had a grid with colors, here's my house. Admittedly, I didn't spend a lot of time coloring in the lines, but what you see here is two colors, and then I have a roof and a door and two windows. Okay. Take that image, and I basically, with letters, wrote either a W or a B. So you could imagine that I could just send my friend, whoever, 49 letters in a row, and they should be able to take each letter one at a time, starting in the upper left-hand corner, drawing basically based off of the letter into a square, into a grid that they know about. So if I tell them draw a 7x7 grid, and then starting in the upper left-hand side, work your way across, and then once you finish one line, one row, go to the next row or the next line. They should be able to create this image. Could have used numbers. Okay, so the one that we would quote-unquote expect in computing is, okay, use 0 and 1. But you don't have to do that, at least not in this first example. I have a few other number systems here. I did 0, 1. I did where you count. I mean, this could have been any two numbers, right? Excuse me. But here's another example where all of the white locations are just the numbers in sequence. So 1, 2, 3, 0. So only the zeros really matter in my example here in this second one. The zeros are all of the black squares, and all of the other numbers just represent a white square. So that could be an encoding that might try to throw somebody off. Right? Like maybe if I was trying to send this in secret, somebody might make some assumptions about my encoding, but really the only thing that matters are zeros. The flip side of that is the only thing that matters, and the one below it are all the zeros are white and all of the positive numbers are black. So yeah, so that's two different encodings, but there are many, many more encodings that you could have chosen. Alright, so the next question that I had for you after you did this was, what happens if you went from a 7x7 grid essentially, and you basically cut your squares in half? Well, you go from 7x7 to 14x14, so you go from 49 numbers, right, or 49 squares, to 196. So it's going to take a lot longer to do. But what should happen to the overall image? I didn't draw it because, well, it'll take a while. But you should see much higher accuracy. Your image is going to become much clearer. Your resolution will be much better. Okay, the next question was, what if you start using different colors? So still squares, but instead of just having the options of just two colors, you have three. Well, now your encoding system might actually become, and let's use green since I didn't use it here. It might actually become zeros for anywhere that is white. And then you can start picking colors if you wanted to be really good in overlap. Maybe all the black ones become 1. Maybe the reds become 2s. Sorry, I know that's really hard to read, especially if you're red-green colorblind, but I labeled a 2 on top of there. Let me actually do better than that. Sorry. Okay. 1 second. Let me change my eraser. Nope, that would be really bad. Let's do this. So those are 2s. and then everything else might be a 3. Alright, and so then you would have to have some algorithm that would say where you see 0, you basically leave that square white. Where you see a 1, you make that square black. Where you see a 2, you make that square red. And where you see a 3, you make that square blue. Alright, and you could be much more complex than that as well. And then the next question that I had for you was, if you use triangles, what can you do? Well, you can actually, I mean, depending on how your triangles are made. So here's one option where you have an offset grid. You know, your image might, maybe you can get more precision, you can make some more interesting shapes. But there's some complexity in terms of this offset that I have here. Another option for making triangles might actually be to subdivide the square. And if you do that, right, you can both make square objects, right? If I were to color these both in black, I could make one total black square. But I can also, if I choose to, I can color them differently. And I can obviously make much more complex shapes. I could, and then this would actually follow a pretty nice encoding as long as I knew which way the diagonals were going. I could make some, I could actually do the exact same process I did before. In this case, instead of, we're basically looking at instead of looking at just 7 items, or 7 by 7, right, even though our squares are 7 by 7, we've effectively divided everything in half. And our total number of blocks per row, you can double check this, is actually still 14. It happens to be 14 triangles. But yeah, so that will actually help us out. Yeah, alright, so there is another option for making these triangles. Sorry it's a mess, but instead of just doing one diagonal, let me just zoom in on one of these, you could imagine doing that. Now the question is, what pattern are you going to use to describe internally here what's going on? Right? Are you going to say, I'm going to give you 4 numbers for each of these blocks. My ordering is going to be this one. I mean, what ordering are you going to do? So that's going to be something that you'd have to discuss in your algorithm. And right, so the other thing to consider is when you start using these different shapes, how will you communicate that to the person, right? If I just give you a sequence of numbers, let's just say 0, 1, 1, 0, 1, 1, 1. Let's see. Let me do 4, 7. If I gave you that sequence of numbers, how do you know if this is 2 sets of 7? Hopefully that's 7. And that would relate back to 2 initial rows in our very first diagram up here. How do you know if it's that? The first 2 up here, no, that doesn't match up. Or if it's actually one of these rows that has 14, right? When you're only setting the data, it's really hard to understand how that data is supposed to be used. So these are things to consider. So thanks for listening, and please reach out with questions, or if you are looking for ideas in terms of how you might be able to incorporate it, I'd love to chat with you. Thank you.